Done. Stage is yours.
Okay, folks, thanks for having me. My name is Eduardo Bellani. I usually work in the technology field, mostly with leadership positions these days. I'm old. And I'm here to present about hylomorphism and the software field, right? In my opinion, it's a solution for deep problems that we have in our field. I'll be looking. Let me just put this on this other area here so I can look at you guys and present at the same time.
Your EXWM bugged, by the way.
Oh, crap.
Wait, now I think it's okay. We can see now.
Okay. Lemos, you can put the crap on YouTube. It's fine. There's so much of it there anyhow. You guys see me? Oh,
Yep.
oh. Okay, cool. Why are we here? Here to talk about, and I apologize for the audience for the fancy terms. I do believe that it pays off to know these terms. So there it goes. We're here to talk about hylomorphism and how it can be a solution or can be the solution, in my opinion. It's a little stronger than that for deep problems in the software field. Why are we here? Here to talk about a fundamental ontological error, which is uh, a particular error that infests our field that leads to very practical consequences, right? And these consequences, I don't believe, can be fixed without fixing this error that lies underneath them. Ontology, for those of you who do not know, it's the study of what reality consists of, right? So how this presentation is going to proceed? I mean, people will interrupt me with questions if they so desire, but the presentation is structured in this particular manner. We're going to start with a couple of specific cases that I've stumbled upon in my career. Their characteristics of problems and the consequences, the practical and economic consequences that they bring about. I'm going to trace or going to try to trace the roots to this particular problem. Just showcase this one of the founders of this problem, this ontological problem, and then I'm going to present the alternative and how you would solve these practical errors. So case number one, microservice architecture, right? This is the definition that I'm going to use. It's a pattern that structures a system as a collection of independently deployable services, right? That communicate only via messages passing through service interfaces. So services in the sense of processes, right? Unix or otherwise. So operating system processes. They're very tied to operating systems and execution frameworks. Right? They're actually computing devices. So, what are the properties of a microservices architecture, in my opinion? There is a confusion of modules with instances or execution objects, right? So, what things are and what things are run as. So, a good example of that is you can have a client and server module, like two modules, and you can have 2,000 clients in one server or 10 servers. Right? Logically, you have only two entities, but execution wise, you can have thousands. But Microsoft architecture tends to confuse these two things. It also confuses modules, these structures, architecture structures with work assignment structures. So a particular team will work on a particular microservice. That's very common in the industry, and that's basically a confusion. Right? These things need not be the same thing. Right? They can map to each other certainly. They do not. They are not the same thing. It also sacrifices simplicity for the sake of performance and scalability because you have a logical uh, architecture or logical entity being forced upon an execution entity, right? So you need to have a process that needs to map to a logical structure or module. It also tends to use quite substantially schema on read. So it tends to, it's usually associated with no SQL databases that do not provide a coherence layer. And then you have structure of truth spread all over the place. Everyone hearing me? Am I here? Like feedback
Yeah.
would be nice. Okay, cool. So that's my take, right? I know that there are different definitions. I think this captures the essence of what I've seen, right? At least it's compatible with the definition, but also these properties tend to flow from that. The schema on reads, it's more subtle, but it flows from this particular part here that you only communicate via messages. So the microservices tend not to share a particular database management system, and then the schema tends to live, or it doesn't matter if the schema lives only in the application logically in this definition. So what happens is that the databases are schema free because people think that they will have more flexibility and move faster with that. Of course, this all breaks down when you have multiple services just communicating through a DBMS or sharing that. But anyhow, that's usually the case. Some consequences of that. It forces the logical structure to adapt to the execution structure. So it twists the architecture into this shape, right? That's necessary or seen as necessary for scalability. Potentially compromises safety of like logical safety soundness for the sake of scalability. Well, the thing about eventual consistency, which is severely well, there are deep problems here, but that's not the point. It also creates a distributed system by definition, usually with little tooling to support it. So, for instance, when you're doing a distributed services on the JVM, right, a distributed application, the JVM, you have stack traces. You have the whole VM provides support for debugging thread problems, etc. Right? When you're dealing with like a multi-language service architecture, like they have things on Go, PHP, .NET, and etc., you have no tooling. Right? Then you have to adopt some third-party tooling to have like distributed tracing. You're basically re-implementing a virtual machine to deal with these things. And of course, like usually ad hoc, usually people not particularly trained in developing this tooling, and it's usually poor. And again, sacrificing consistency, which leads to severe bugs and increases, in my opinion, the maintenance cost exponential. The system gets worse and worse as time goes by. It gets more and more expensive. That's case number one. So case number two, it's a little more abstract, but I'll try to make it as more concrete. So conceptual, logical, and physical confusion, right? So what are the properties? What is this, right? Usually, when people are picking databases, they start thinking about a hash table, right? So, oh, I'm going to pick this man cache or what's the name of this I forgot the name of the fancy one.
Rocks
But
DB.
anyhow, there's rocks. There are several of them, right? So that they're basically fancy hash tables. This is a hash table is right at the physical layer when you're talking about implementing stuff on a computer, right? It's very tied to that. So it obscures the decision. Oh, wow, okay, what's the logical? Sorry, what's the logical layer? You're talking when you're talking logical layer, you're talking about actually mapping business concepts in a language in a data structure, right? So you have dictionaries, you don't have hash tables, right? You're talking, or if you're talking about a database, you have SQL creating a schema. You have tables or relational tables. If you're talking about the BMS, and then you have a conceptual layer, which is basically you're mapping a situation in the world to some language, property, calculus, or anything like some language that can properly abstract from the world. And that language usually is more fluid and more capable of communicating with the stakeholders. And these confusions are all over the place. Some consequences that I've seen obscures the decision of picking an adequate database management system. Right? It makes it increases the chance of people picking an obsolete data model. So every 5 to 10 years, people rediscover the graph model, right? So I think it was 1970 or 1968, something like to that effect, where the first Turing Award was granted to the graph model guy. Right? I think it's programmer as a navigator. Every 10, 5 to 15 years, they rediscover this thing and create a product. The relational model was created to replace that. It is better. It is more. It is mathematically treatable. The graph model is not. And it undermines consistency, right? You create the potential to undermine logical consistency with all the problems that derive from that. Again, increasing the maintenance cost exponentially. You create contradictions in your database. I
Billy,
think,
just one
yes.
thing. I don't know if it's just for me, but your last sentence and like uh, it's being kind of low, like in pitch. So if you can just like tune it up.
You mean my speech?
Yeah, like
You
it's
want
kind
to
of
speak louder?
yes, please. Like it's kind
Oh,
of
sure. Let me
unintelligible.
try. Okay, please let me know if it's better. Let me see if I
Yep,
can
it is.
increase the volume here. La la la.
Yeah, it's fine.
Is it
I can
better?
hear. Yeah, much better.
Okay, I just increased the
Thank
volume.
you.
Thanks for that. So anyway, undermines consistency. Picking database management systems that do not enforce consistency at the database layer does well. Basically, you're exposing your application to inconsistencies. And you can create contradictions, and contradictions are very hard to debug because uh, then you depend on people to understand what is actually true, and they can forget, they can disagree with each other, right? You have multiple sources of truth, and sometimes no one knows. You have denormalized data, which increases the need for more integrity constraints, and worse, they push these integrity constraints to the application layer, makes things much more expensive. And when you're dealing with a microservice architecture, you have different applications consuming the same data. You're starting to duplicate these integrity constraints, and well, they can be different, right? uh, Denormalized data, besides being more like just basically occupying more space, it has this big problem, right? The more you're normalizing your data, the more you have to create software-based integrity constraints. A completely normalized database only needs primary keys. Right? That's the definition. You have access path dependence, right? Graph and hierarchical databases, they have that. That's their main disadvantage. So hierarchies are well fixed, they're hierarchy, right? So if you're trying to access the data in a different path that's not the hierarchy, out of luck. Graphs also impose the hierarchy. It's more you can have more hierarchies because it's a graph, but still, if you're wanting to access the data in a different way that's not represented in your graph, you're out of luck. Uh, anyway, start re-implementing the DBMS features, right? Integrity constraints, transaction management. You have language level support for these things. This is insane, and people are touting that as features. And no concept of logical independence, so views. Like traditional and relational database, you have views to provide that. Nowadays, they're recreating that with GraphQL, which you can see the cycle. Right? People forget things, try to implement things at application level, etc., etc., etc. That's so, my opinion, the root of these problems, the source of it is reductionism. So what is common to all of them? It's a bottom-up approach to reality. So uh, you can you can search for like physicalism, reductionism, or physical reductionism, etc. But it's the view that things, stuff, what is basically the parts that is consisted of. Right? So a table is not a table. It's nothing but a collection of particles which give you the illusion of a table. Right? And you can see how that applies to what I've just said. A system is not really a system; it's a collection of services. A database is not really a database. It's a collection of tables or hash maps or just bits on a disk or etc. So you can see it approaches the problem bottom up, like, much as people these days do with everything around them. I think it's basically a mental habit. So, okay. So the origins, you can trace these in a number of ways, even further than Descartes. But I think Descartes has a very strong case for being the father of physicalist reductionism, the modern version. Although these days he's very much out of fashion because he was a dualist. He believed in the existence of the soul, but his definition of the soul was basically the ghost in the machine. He still believed that things are machines, but uh, they believe that there is this thing that possesses them, which is a soul. So Descartes believed in a very ancient philosophy called mechanism, which is all over the place these days. Then eventually people did like basically discarded the soul, and but stayed with his idea of how reality is structured. So the solution, an old idea, it's called hylomorphism, which basically claims that a dog is a dog. It's not a collection of dog parts, right? When you see like a tree, a person, or a stone, what you're actually seeing are again not a collection of parts. And all of the schools of thought that derive from this. So it comes from the Greek, highly, it's matter. So hylomorphism is this combination of matter and form, and they're they're distinguishable, but they're inseparable, right? In actual reality. Um, well, and then you have this idea of substance as organization structure, right? And like structural substance is what a thing is, right? It's what makes a dog a dog. It's the dogicity, right? It's a substantial form of that particular being. And there's more, right? When you dig into hylomorphism, you have a causal theory which explains how things come to be, and it's this fourfold uh, path, if you will. And then you have material, formal, final, and efficient cause. And what materialists or mechanists such as Descartes did is that they only see reality in terms of material and efficient cause. I'm going to get to that, but they only take two of these to explain everything. So an example, like for a concrete case, usually just for you, those of you who don't know, like Aristotle's thing was biology, right? So his analysis was abstracted away from living things, which it's a better model for reality in general. So a heart, you cannot explain a heart except as something that has a matter, right? But it also has a particular form, right? It's shaped not only like physically, but like in terms of processes, in terms of its behavior on time, right? And etc. In terms of its acidity, all of that, it's a principle, and it serves a function, right? That it is how we explain organs. Like when you're dealing with organs, you're talking all the time about functions, and then you also have the efficient cause, right? How it came to be, or what caused it to be, and then you have a genetic programming, etc., and how life comes to be in general. So causes, right? The final causes, I think it's the key element that will explain a lot of problems in our field, right? Everything has an objective purpose for hylomorphism, and when you say purpose, you have to deconstruct this word, or at least see that it's overloaded. It's not necessarily conscious goals or conscious purposes. A rock can have a purpose, magma has a purpose, and it's explained in those terms, right? It's there for pushing something out of out of the way and then creating the necessary structures to do something else. We're talking about purposes all the time, if you figure out, even for inanimate objects. And then you have the third way of explaining purpose, which is the best that the thing can be. So, use an example of an apple tree that had no apples, like it died before like giving apples, uh, did not fulfill its goal. So the best that something can flourish towards is its goal. So you have these three ways of talking about goals: conscious, which only people have, and then you have like the cause of something, like what it serves for, and then you have the final cause of something which is the best it can forge towards. So these three things. So what's the difference? Like I said, this both the regular raw materialism and Cartesian dualism, which they're both mechanisms, they just throw away formal and final causes, right? And they only have matter and causality, right? Efficient causality. So how does it apply to software projects? How does it solve this? Like I'm going to just present here how I would apply these to projects, right? How we can structure our projects in these terms. So you have the material cause, which is your binary is running on a machine, be it on AWS or whatever, right? And you have memories, you have network, you have cables, you have data flows, you have things happening, right? Electrons flowing to and by. You have formal causes, which are the architecture, like what people usually call by architecture, abstractions, and the actual abstract data flows, how things will receive messages and respond, and how we structure it, modules, etc. You have the efficient cause, which is programmers typing away in a keyboard or whatever, right, or even a paper, structuring themselves in teams and like generating the source code and clicking buttons. And then the final cause, which is, I think, the crux of the matter, which usually gets lost in this efficient material bonanza, which is these systems are there for creating value to some consumer that wants to input information and either gets a promise or a factory out in some way, right? Get information back or do some transaction or establish a contract. All of that should always be in mind, right? The software has a final cause. Usually that's the final cause. So consequences I will take out of this, right? You have propositions, which is a way to structure reality. I don't know any other way to logically structure reality. Uh, when you're structuring something, you need to assume that you are exhausting the space that you're talking about, at least in terms of your subjective opinion of it. So I think this is such and such at this time. This is a proposition, and you cannot think something else at that time about that thing. It's a contradiction. Bad things happen when you have contradictions. So architecture, the form as an expression, right? The architecture system should be the expression of the form, and then you have coherence mattering a lot, right? Having uh, incoherent architecture produces bad effects, and so a type system becomes crucial in order to have a mechanical way to enforce that. As humans, we're very limited, and functional programming to basically express data flows, which is most of how reality is expressed. To have data like what the final cause is expressed is usually in terms of data flow, not actually changing bits on a computer and mutating variables. Like people actually think in terms of I'm going to put data here and expect data back or expect a promise, expect a contract, expect something happening, right? That's it. And welcome to questions. Let me put the references here. Interface. Hi.
Okay, so I have a question. Can I start then?
Go ahead. Man.
Okay, so from your point of view, in terms of, for now, just software, how this came to be? Why software went through this path that we are right now of microservices instead of this other alternative explanation that you just gave?
Because that's the culture we live in. I think people just reflect their metaphysical outlook from their profession. I don't. People actually think that the reality.
And I lost it. You were talking about reflecting the culture on the profession. and then I got jobs.
Yes, people tend to act in what they believe, unless they're insane, which is the case with people in general, but not constantly. So the metaphysical outlook of people these days is that reality is composed of matter and efficient causes, in such a way that matter makes matter moves, and reality is composed only on that. And then they try to reflect that in software. Like
Mm,
there's no system per se with a final cause and an architecture. There's a collection of parts that will eventually work. Go ahead. Market. Is that is
My
that is that clear,
yeah,
Doctor
no,
Nekoma?
no, yeah, that answered my question. Yes, thanks.
I agree with the worldview being reflected on what people do, but I start to think, doesn't you said like one core concept of what you're saying is that people don't get they don't think at least of the final cause, right? But then it raises me the question, don't they? Because from from the people I've argued on the past, they do have a final cause. I just think it is a final cause with without without the clear distinction between the abstraction part that you mentioned, which is the logical part, right? So, for example, picking the database, I think that's the easiest one. You start to see the database is a collection of tables instead of like a collection of relations, right? Interacting together. So, like, what do you think on people? Because I do think they have a final cause, but how do you determine? Uh,
Well, I don't think they are capable. No one's capable of interacting with their environment without this tool, right? It's embedded in operating the world as is because the world is like that.
mhm.
I think they eventually do try, like they all systems have requirements and etc. It's just that I think the ontological makeup of people is crazy, right? And people operate with this cognitive dissonance, and they try very hard to actually create systems that reflect their insanity, and then you
Mhm.
have crazy systems. The microservice architecture for me is a perfect example of people trying to do atoms,
Yeah,
atomic
that
reality, right?
that's
Eventually,
what I'm
this
going to
thing will
say.
generate a table.
Hmm.
If we just pile enough atoms, it's going to be a table for God's
Yeah,
sake, use, right?
that's a good point. Because I'm working. I'll not say who, but anyway, but anyway, I worked with a system that is basically I can totally see the path in there. Like you have the database that doesn't enforce that is totally inconsistent. It is not a relational database. It should be. It is a in theory like it is a SQL
It
database, but it's not.
supports it supports
It
relational.
supports that,
Yes.
yes, but it is not a relational database at this point. There is no guarantees, and by consequence, all the hierarchy of the system, like the microservices built on top of it, and all the rest, they've been built in a philosophy of don't trust anything. So you don't have any source of decision, any source of truth in the system itself. It is just an amalgamation of of like
Stuff,
yeah,
and you don't have form, right? You don't
yeah.
have the
You
formal
can see the
content.
form. That's interesting. Yeah.
You can it starts to blur, but people still talk as if there will be a form. I mean,
Yes.
even when you say the word microservice architecture, that's a form.
Yeah. Hmm.
It's a formless form, but still a form. But you're trying to do that, like you have all these messages,
Hmm. Interesting.
and you can see that it's all it. In my opinion, it's the underlying issue is this physicalist reduction, right? They are trying to implement atomic structures.
Hmm. That's a good point, actually. I think most people would say it's a stretch, right? To link both. I can see how. Uh,
I don't think most people are even aware that this thing exists. To be honest,
well, could be.
the reason that I found people justifying themselves usually it's scalability,
Hmm.
right? Because you can easily tie a microservice to to a object, right? When I say object, I mean a binary object, right? Something that can run on a Docker, right?
Mm-hmm.
So that you can deployable artifacts,
Mm-hmm.
and then that can be on a machine, etc. I don't buy that. I don't think that's the case. There's nothing that pertains to microservices that makes them more scalable than anything else. You can just have copies of a big system.
Mm-hmm. Yeah, that's something.
I have a question. So I actually, it is like a combo, two questions, but I think they are very closely related. So how do you approach when like you start working in a new company and then they use microservices? My first question is how difficult it is to convince them to think otherwise. And if they do think otherwise, if you convince them, what is the best approach to transform the microservice formulas architecture to something the alternative solution that you just described?
Well, I'm not a rhetorician, so I don't know how to convince people, right? I'm not an expert at that. I fail all the time at convincing people of stuff. Uh, I just explain my case. Depends on the level of power that I have, right? So it depends, like Aristotle says, like ethos, pathos, logos. It depends who you are first. Then depends on the feelings that people have about stuff, and then only then you have logic. So the first part is I don't know. The second part is the way that I would approach is replacing the database management system.
Okay.
Work at the DBMS layer. If you have a microservice architecture that's all communicating with a data layer, the same data layer, it's easy. But if they all are just communicating with different database management systems, right? You have a user table here, and then on SQL Server, and then you have a row table on MongoDB, or not. I don't even know what that thing is. It's not a table, it's a document. So you see, it becomes very hard very fast because then you don't have consistency guarantees, even within the same DBMS. Like Mongo doesn't provide consistency guarantees. So even if the other DBMS provides them, the other one doesn't. So, and then you have the distributed system. Then you have the weird parts that I've seen people trying to do is they start re-implementing DBMS features on the microservices, trying to achieve consistency. So you
Oh.
communicate with the other and say, "Hey, you already have that. Lock it, like two-phase
Yeah.
locking."
Oh. That
You
sounds
start
bad.
super, but you have it, right? When you have global invariances that you need to maintain,
Mm-hmm.
which is the form of when you're talking about global invariance, what you're talking about is the form of your system, and you need to maintain it somehow.
Do you think that changing the database will kind of like reverberate throughout the rest of the software because people, oh, we need to accommodate this database architecture. We can't have microservices anymore. So they will be forced to change it, kind of.
Oh, it's force. Go
I
ahead. Sorry.
wait me.
Yeah, you're talking. Go ahead. I
No,
don't want to.
I was just gonna make a comment because it's my opinion. But I think only the database doesn't help on that case. It it does change the entire worldview as far as I can I can say. But I don't think, for example, let me give you a practical example. Like you may have a very consistent database, but if you go and implement like the domain all over again in like the in like our choice language, like using classes and so on, then you're kind of shadowing over what is on the database, right? You're now like working as an abstract entity that is just like Java or .NET or something like this. So as so what I'm saying is like you may still lose it along the way, you know? Like
Okay,
that's
so it's not
my
enough. The database is not enough. It is a
yeah.
start, but it's not enough then.
It's a good impact, I would say. Like it's better than having something without any form, right? Because at least in a like I don't know, if you're doing a domain layer, you're at least thinking of what to conform with, right? So you have a target form that you need to achieve. But if you don't even have that, like then that's worse. But you can still like miss that form, you know, the target. So
Yeah, but if you have a proper DBMS and you've thought about the scheme and the structure, at least you have the. It's required. It's
mhm.
not necessary, but it is required. If you don't have that, oh, hell, I mean, the game's over.
Mhm.
Yeah, you can even you
And
can't even start playing the game, I guess.
yes,
Yeah, okay. Okay, that makes a lot of sense, this answer. Thanks for that. And that thing that you said about synchronizing databases with microservices, that was a new one to my knowledge.
Oh, that's CQRS, by the way. Just look, it's a
But
design pattern.
okay.
Oh man, it's you just search around these things, man. It's very easy when you have what is a DBMS, right? What is the requirements, the integrity constraints that you need to enforce, and then you start seeing the microservice oriented libraries. You can see that they're implementing that.
Yeah.
They're implementing distributed databases,
Hmm.
like without even realizing it. I've seen people doing it, man. Like in local on a merge request, right? Oh, I have this mobile app, and I'm going to use this hash table oriented database, right? I said, dude, use SQLite. It has transactions. Oh, this is faster, and then he did it. And then like 3 weeks later, he was like there was this consistency error, and then he was implementing transactions. And I've seen the code for transactions. He was trying to do transactions, like, oh, don't mess with this if this does not exist. And he wasn't aware. He was just doing like business things, right? Oh, this is buggy. You shouldn't mess with one thing if the other because it doesn't make sense.
I have a
Hmm.
question. I think it's two questions actually. But one thing, you said that a good functional languages with strong data types are a good model for data flow uh,
Yes.
applications, I guess. What about interactive systems? So, like, if you take Emacs, what is the input of Emacs? What is the output of Emacs? I don't think it fits that characterization well. What is the like the fitting in this framework of something like an interactive application?
Well, all interactions, in my opinion, is you're inputting information and you're expecting some information back, or you're expecting some contract, a promise. So when you click on a shopping cart, you might not expect, although you usually expect confirmation at the very least, but you also expect a promise. The system is promising that something will happen in the outside world. But same with Emacs, you're inputting characters and expecting like a display to change, right?
Can you make the question again, Breno?
Yeah, basically that functional languages model data transformations well. But
Because
what if your workflow is not a data transformation? So it's like an interactive system.
when you say this, like Smalltalk and Lisp come to mind, right? Because
Yeah, that's kind of what I'm thinking
you
about.
have the data itself. You don't have like another entity that is handling those things for you. I mean, you do, but that's like the implementation part, right? Like thinking more abstractly, that would be the thing itself. So like Lisp, you have the code as the data. So I don't know if it fits that condition, but is I don't know how Smalltalk works to be honest. But I don't know. I think it could be classified as the whole environment, maybe.
Right. Yeah, I think that let's take another example. I think a web server, for instance, like it's not something that terminates. It takes
Mhm.
requests. Like you can think of the request as an input and the
Yeah, but
response as an output.
even in a web service, like you still have input and output, right? You still
Right.
have a like you still have that part of data flow in something that is interactive, right? It's just like smaller.
Yeah, I'm thinking about situations like where internal state becomes relevant. I'm gonna lead this to my next question. That basically, so okay, you may want to implement your microservice with like Redis and all the fancy
Redis,
language
thank you, man. I
technologies.
had forgotten that name. Redis, thank you.
Yeah,
My
yeah.
nemesis.
It's been causing me pain, so that's why I'm bringing that up.
Ah,
But
why,
the
man?
thing the thing that I wanna okay, consistency is not easy, like hardware wise or efficiency wise, to implement consistency. So the main problem that people come up with when we're using relational databases in a large scale is that the database sometimes just locks up or something like that because it's trying to maintain consistency. So it's like it's doing some cleanup job or something. Do you think there are cases where it's legitimate to add consistency in the application layer in cases where the consistency of the database system does not fit your like requirements? So if you think of your
I'm going to,
final,
yeah,
go ahead.
I'll go ahead. Go ahead. No, no, finish the question. I'm sorry.
Yeah. So like if you add to your final cause, like not just take this as input, produce value. I don't know. So but like produce value in 5 milliseconds or less, and like don't lock up or something like that.
Well, that can be a business goal certainly. I don't see how that, because here's the thing, there's senses in which the word consistency is used. Like consistency, in my view, means maintaining integrity constraints. That's it. Right? The integrity constraints that make up the form of your system. If you do not have them, your system is game over. You can produce anything out of a system that does not have integrity constraints. You can sum an apple with 340 trucks. And what the heck does that mean? Right? And then you display that to the user as a monkey. But there's no integrity constraints, right? 1 plus 0 can be the Pope. Right? That's one sense in which integrity constraints in the relational data model is used. Now you can say the value of the shirt in this store can be not the same as the value of the shirt in this other store, and that's fine. Return what's faster. You
Ah,
just,
okay.
if you do not put that in your DBMS, that's fine.
Right. Okay. So I think it's a matter of modeling your, because I'm
Yes,
thinking of the case, for
it's a
instance, where
matter
you
of
have,
representing reality in the way
yeah,
that's proper for your form and your final cause. You see?
right.
Makes sense.
Okay, that makes sense.
Oh, by the way, I'm taking this straight out of SQL and Relational Theory, book by CJ Dates. He has an appendix just crapping all over NoSQL. It's fantastic. It's a cathartic experience. Uh,
I, I
eh,
think what woke me up, just a comment here. I think what woke me up, favorite novel. I think what woke me up on SQL and how bad it
you
is.
should wear a shirt. What woke me up?
SQL is bad. Yeah, woke me up. Yeah, but it was when I saw relvars and how SQL hides that. Uh, because like in the relational model, you would have like a variable, right, to represent the relations and then how it alters itself over time. So everything like an update is an assignment to that variable. Uh, but on SQL, it's like just a magic box that you just like input something and it gives you something back, like mutates the table, whatever. So I think like these tiny things that they start to they start to make you like do something skewed that you weren't supposed to do, like null, for example. You start to handle null as just a flag and not like as a value I don't have and I yet to find this value. So like it prevents you from like I don't know, normalizing the table, like something like this. So
Yeah, you're representing metadata as data. It's confuses them.
yeah, that's
Again,
a good point. Yeah.
yeah. All it takes for you to do these things properly is just being clear on what you intend and just writing that down. So a lot of errors, for instance, is this thing is X instead of I believe this thing is X at this time. That's a valid proposition about
Mhm.
reality.
Yeah.
And if you do that, you have historical data, right?
And
Go ahead.
that's pretty fun to say that way because the purpose of the relational model is to provide you propositions, right? Like every
That's
line
it.
should be like something true, like that is in our system. So
Yes, and a proposition should be exhaustive, like a table, a collection of propositions should be exhaustive. That predicate should
mhm,
represent everything in that universe you're representing.
yeah,
Everything that is true about that thing is there,
mhm.
and nothing that's not there is true. The closed word assumption that
That
would
is a
fix a
very
lot of stuff.
different way of explaining that. Blew my mind.
A database is an interlocking set of propositions
Yeah,
that exhaustively describe the universe you're trying to represent. That is it.
Mhm.
yeah, but I never thought that way. That makes total sense
Yeah,
now.
I bet you swapped for the implementation, right? Which is a place where you
Table.
store stuff.
It
Like,
stores stuff and you mutate it on the computer and you see where that I'm going with this, right?
Oh,
mhm.
I was aware of the whole relational databases are a set of relations, like abstractively speaking, and not a set of tables. But I never thought about it in that way of like it is representing every single possible instance of this universe. Like that's different. Thanks for that.
You're welcome. Even the math part, the relations are supposed to just underline that,
Yeah.
right? The relations are not like the end in itself. They are just a way
People
for you to
people
consist.
think people forget to think that relations they act upon sets, right? Domains. So that is they just think of the domain part, like which is just a story.
Oh, by the way, I've told that to Mageta. I don't think he believed me at that time. If you think programming languages are bad, you should like when you go after database world, it's an order of magnitude worse. The confusion and the
Now I
weirdness.
understand that.
Yes, it's much much worse.
But I want to bring a counterpoint to this argument. It seems like from my, I guess,
Wait, you're bringing
non-nuanced.
counterpoints to my arguments? I will
No,
cancel you.
that thing about the database world being worse than programming languages. It feels like they got it right relatively early on, whereas with programming languages, it took some time for the theory to develop. And I wonder why there's so much confusion. I was looking up the common case that comes up is what is the definition of the normal forms? So like there's if you look up whatever normal form you want, there's like 10 different definitions, so you can't get a straight answer.
I,
So I wonder why
really,
that
this
happened.
moment, I've been getting paranoid. I open like a description of a normal form, and I can list like the errors. Like this is wrong. Like anyway, just go on.
They're very
Ruins
precise.
your life. That's what I'm saying.
I've told Mageta that too, man. CJ Date and these guys, they just ruin their career, man. They make staying at jobs harder. I have a particular thing that I do when I got to jobs and I talk to data people. I ask them to just explain me the difference between a table and a relation. And 10 out of 10, no one got it right.
And what is the answer? How would you say?
And these are data engineers, man. Senior data engineers. People who make a lot of money. And they can't even tell me that. Like, do you see the level? That's a person who cannot tell you what a function is or a for loop. What is the difference? A table has an order, left to right. You can have duplicates. Sets have no duplicates. So a mathematical relation has no ordering nor
No
duplication.
ordering on the header, right? And no
Yeah, no,
order also on the rows.
oh,
Like this SQL
no
does.
rows and no duplication. And SQL has all three of them.
Mhm.
You have cursors on the tuple rows, not tuples. You have orders cursors on the columns, right? Something comes before the other, right? And you have duplicates.
I don't give a spoiler because I'm gonna talk about normal forms.
Oh, but by the way, you think they got it right, and yet on the major abstraction of the thing, they got it 3 out of 3 wrong.
Yeah, I can see. But here's the thing that like that I got really worried because okay, I woke up on the other like, oh, this is bad, right? But how bad can it be?
It gets more
Uh,
bad.
and then it was when I saw first a description on first normal form, and what I remembered was like having composite data, but I never stopped to question myself. Okay, what is complex like composite data? Like telephone. That's usually the example people give, but that's totally wrong. Like it's not because you have duplicated fields of like a telephone that you should suppose that that thing doesn't conform to the relation. The problem would be okay, is the proper way to frame the first normal form would be does it conform with the header, like, and that's
Yes.
it, like, and that solves all the issues. So this telephone example is just a dummy example. So
I think of it as this proposition represents a thing. Can every single thing that's supposed to be represented by this proposition is actually being represented? It's a type.
mm, yeah.
So you have a set of things. You say these are all apples, and then you have a car.
Dude, it's like it's funny because it is like types as propositions and values as
Yes, exactly. But because that's what they are,
Yes.
right? And that's first normal form. Just talk about the same stuff when you're
Hmm.
actually having a collection of the same stuff. What you have when you don't have first formal form is the application saying, this is one stuff, this is one stuff, this is one stuff, this is a dinosaur, this is another stuff, right?
Yeah.
And you have basically, but it's more efficient, or so I've heard. Folks, any other questions?
For me, that's it.
Can you guys give me feedback?
Oh, I'm also done with the questions. And about feedback, I'm Magetta, you can go first.
Uh, I have I have a feedback on the how you presented. I think it was too. Sometimes I felt like it was too fast. In the sense of you were talking. I mean, I think I got the idea behind it, but I think it was too disconnected in the middle of the talk. Like sometimes I was thinking, okay, where is he going to? Like on this part. But apart from that, I think like in the end you mended that well. I just maybe like you might lose somebody there, so that's my
Okay.
only problem.
I thought the same. I think it's a bit loose in the middle. I don't think I should present the cards. I don't think it brings anything.
Yeah, I was thinking. Yeah, I was thinking about that. Like talking about what he like, it's useful, but I don't think it is a central point.
Yeah,
It's more if you want to know where it came from, but I don't think most people are interested in that.
exactly. It's a distraction to talk. I agree.
Um,
Well, I'm
go
gonna
back.
say no. Actually, I thought there was a good like hook because I think I got situated better when you mentioned the card. So I don't know. Take from that what you will. I like historical examples, I guess. So
Yeah, I
because
think it's
it's
cool.
really an abstract topic, so like maybe anchoring this in things that people like understand, or, like have an idea of what it's about.
Yeah, it's very weird. Since that time, I think people just. Well, anyhow, uh, I don't think any of these problems will ever arise if people just maintain the idea of form. Right? There's a form that we're trying to represent in the system instead of a collection of stuff.
I think you should have started saying that. Like the
Yeah,
first slide
that's
should
what I
be,
mean.
keep this in mind. Form is important, and then you start.
No, that's a good point. I'll think about it. It's a complex topic. By the way, I really like that book by Edward Fieser. If you guys are interested in that, it's very short and very good. And there's audio.
Which one is that?
Introduction to the Philosophy of Mind, if I'm not
Yeah, I was
mistaken.
gonna ask if you can share the slides because
Magetta
there's
has
some
the slides
things I want to
already.
go. Oh, cool. I want to go back on some
Yeah,
things.
it's called Philosophy of Mind, the Beginner's Guide. You can find, I mean, are we recording this? No,
Yeah.
right?
No, we still are.
Okay, good. So that's it. Not going to say where you can find it, but there are audiobooks.
Yeah. Okay, that's fair.
You can find it on Amazon.
Sorry, on Amazon. Let's censor
Uh,
that part. Nobody saw.
Uh,
okay, and your nearest bookstore. It's a fantastic book. It sums up very well the philosophy, because once philosophy has this quirk about, and especially philosophy of mind, where when you talk deeply about any part of it, you reach everything very fast. If you're actually meaningfully talking about any part of philosophy, and then he reaches basically hylomorphism and mechanism and etc.
I have some feedback also.
Go
So,
ahead.
the thing that you did at the end about making the parallel of like, okay, we have these topics like efficient, final, um,
Material
material,
and formal.
and yes, exactly as you. Well, you did with our field, right? With our field
Yes.
of, I would I would like to see how the opposition side would interpret this. Like the same thing that you divided the resources between the your model. What about making the same but to the other model with the
I don't think it's
microservices?
possible. That's
No,
the
but
thing.
You
it's
don't
gonna be
have
clear.
categories. How do you
That's
do
gonna
that?
be more clear. That's
Yeah,
the
but
point.
that's it's weird. For instance, how do they represent architecture in terms of material and efficient causes? They can't. It's impossible.
Well,
You cannot represent an architecture of a system in terms of things bumping against each other.
yeah, but like some visualization of that not being possible. That's my feedback. I would like to see that.
No, it's fine. I'm just asking how can I visually represent something that's not possibly representable.
Yeah, I think you could have added that. That's a good point.
It's a good point. It's a good point. I'll just put that and put like a question mark, right? Oh, I can use no.
Oh man,
Okay,
like
so it's,
I think I sent a a, a post right from Fabian Pascal that I literally read that and I said, dude, that's like the very system that I'm working with. Like it describes exactly what happened to it. And then you have like something like, for example, like a column there that is null. Like, and then you think, okay, like what the things were starting to get very complex. It's not like normalized by any means. So they started making views where you insert on like things and then you like send stuff to like a bunch of tables, right? So you have like I don't know extension table, and that extension table is like some duplicates because the storage is cheap, so you just duplicate. So you have duplicates and you link somewhere else, blah blah blah, and then to make a join, like just to query one thing, it is like literally three joins on different three tables. Like I was thinking, like this got really out of hand, and like I don't know how to say when. Like I if I were to say it was like when people started inserting like nulls and a bunch of stuff. Like nulls are evil.
Yeah, no,
uh,
you're gonna make a presentation about that. I'm gonna force you to do it. The title will be a new rant. That's gonna be the
Null
title. But
rent.
that's future plans.
Oh, that could be many things. I'll find the post. It is really really
Uh,
like
and
GCP Date has an article about much ado about nothing.
oh man, let me see.
anyway, thanks
His
Belani for the
titles on those
presentation.
are great. Likewise, dudes. Nice to see you all, by the way.
Thank you.